So chapter 6 is kind of the last really big chapter we have to do. It's a long chapter. We get 2 class weeks instead of 1 class week before we get the test. The test is worth 150 points, so there's a lot here. But once we get done with chapter 6, it's kind of downhill. Chapter 8's not that bad. There is no chapter 7, and then chapter 9 doesn't have a test. It just has a take-home assignment. I typed up a bunch of stuff. I don't know how much I like it or not, but I'm going to live with what I have written here and just try to work with it. So problem 1 gives me 2 functions, a function called f of x and a function called g of x. And the first thing it asks me to find is g composed with f of x. And my hint was here, this is the same as g of f of x. And what that tells us to do is to take any of the x's in the g function and change them to f of x. And so that's going to be 7 times f of x minus 5. What I wrote here is this g of f of x, to do it, you need to replace any x in the right side of the g function with the entire f function and then simplify. This is kind of what I wrote here, and this is what I'm doing. I started off, took the x in the g function, and I replaced it with f of x. And now I'm going to change the f of x to x squared minus 2x plus 1. I'm still going to leave the minus 5. I'm going to clear the parentheses by multiplying through by 7. I'll go 7 times x squared, 7 times minus 2x, 7 times plus 1. I'm not going to do 7 times minus 5 because the minus 5 is not in the parentheses. And I have something that's really close to an answer. I just have to combine those last 2 terms. I'm going to write the original problem and then what it simplifies to. But if you just write what it simplifies to in your answer and you don't write the original problem back down, that's completely fine. The only things I have to worry about combining when I go to get my answer between this line and the next line is the 1 minus 5. So as I write my answer, I'm going to bring the 7x squared down. I'm going to bring the minus 14x down, and positive 1 minus 5 is negative 4. I don't think that factors, but I'm just going to call that done. I'll leave it there. I'm thinking in my head if it factors, and I don't see how it does. Part B is the friendly part. When we did these kinds of problems, I guess in section 6.1, some of the problems to find the domain of the answer to part A were kind of messy because one or both of the parts were fractions. In this particular problem, because the function for g and the function for f are both polynomials, and polynomials don't have any domain restrictions, there's no algebra to do to find the domain. When you compose 2 polynomials, the domain is just negative to positive infinity, or just you can write all real numbers. And if you do any algebra for this, you'll likely find an x-intercept, which has nothing to do with the domain. So you can just write the interval from negative infinity to infinity, or you can write all real numbers for the domain. Maybe I could say the domain is. So either one of these would be fine for part B. Question 2 is a friendly problem. It gives me kind of a half a parabola of graphed, and it gives it labels 4 points: the point 0, 0, the point 1, 1, the point 4, 2, and the point 9, 3. And I'm told this is the graph of a function f, and I'm asked to draw the graph of f inverse. To draw the graph of f inverse, I need to take every point and switch its x and y, because inverses are created by switching x's and y's. I'm doing the bottom 2 points first because when I switch the x and y, you could actually see the x and y switching. The top 2 points when I switch the x and the y, because the x and the y are the same, they don't look any different. So to graph an inverse, I simply take any point that's given, switch its x and y, create new points, and then plot those new points on the provided graph, and then connect those with the same shape. So this is kind of a half parabola in some sense, so I'm going to draw a half parabola through those, and that's all there is to do for question 2. That's the inverse of the function f. I did some stuff about drawing lines that go through the origin at a 45-degree angle to kind of check yourself. We don't really need to do that here. This is all we need to do is switch the points and connect them with the same shape. 3 is another inverse problem, and it has a part A and a part B. Part A gives me a function which is a cube, and it asks me to find the inverse. And then I gave myself some hints here. First thing I need to do to find the inverse is to change the function notation to xy notation. So the initial problem has function notation. I'm going to change in step 1 of my attempt to find the inverse. I'm going to change the f of x that's given to a y. So that's step 1. Step 2, I'm going to switch the x and the y. So that y is going to become an x. That x is going to become a y. That's technically what the inverse is. The inverse is technically x equals y cubed plus 4. Step 3 wants me to solve for y. I'm going to minus 4 first to get the y solved for. That'll give me x minus 4 equals y cubed. And then I'm going to cube root both sides. I don't need plus or minuses for cube roots. I do for square roots. But I'm going to cube root the left side. And I'm going to cube root the right side. The left side doesn't reduce. It simplifies, or it is simplified already as the cube root of x minus 4. And on the right-hand side, the cube root symbol cancels out a cube and gives me the y. Basically done. Now I've solved it for y. I'm going to go on to step 4 and write my answer. I'm going to replace the y with an f inverse of x symbol, and I'm going to call this the answer to part A of number 3. I'm going to say f inverse of x equals the cubed root of x minus 4. Part B wants me to do algebra, and it's kind of a proof. Really, the part B could just say find f composed with f inverse of x is really what it wants me to do. My answer is correct to part A if I get x back and nothing other than x. So I should know that f composed with f inverse of x is the same as f of f inverse of x. And that means in the f function to change this x right there to the f inverse symbol. So the f function is x cubed plus 4. I'm going to change x cubed plus 4 to f inverse cubed plus 4 because inside the parentheses here, instead of an x, there's an f inverse. So I'm going to write this as f inverse of x cubed plus 4. And now I'm going to change the f inverse symbol to the cube root of x minus 4 because that's what it's equal to. So this is going to be the cube root of x minus 4 cubed plus 4. And cubes cancel out cube roots, just like cube roots cancel out cubes. So on the left-hand side, or on the only side here, I get x minus 4 plus 4, the cube and the cube root cancel. It makes it so I don't really need the parentheses anymore. So that gives me x minus 4 plus 4. The minus 4 and plus 4 cancel, and I'm left with an x. And that's all there is to do for part B. I've checked my answer by finding f composed with f inverse of x, and because it equaled exactly x, then I know my answer is right. For question 4, we've done this a couple times already. Find functions and describe the transformation. And I made a little hint to myself off to the side to help myself out for the part B's. So when the original function that we're working with is an e function, then when we do the find the requested functions, we don't really need parentheses. The exponent's going to work like a parentheses. any number that's inside the parentheses is going to wind up in the exponent. So when I do part A and part D, the exponents are going to change when I find the requested function. But in part B and part C, because there's nothing inside the parentheses, the exponent's not going to change. For 4A, it wants me to find the requested function and describe the transformation. The find the requested function is simply found by changing that x to an x minus 2. So f of x minus 2 equals e to the x minus 2. You could have that x minus 2 in a parentheses. I'll write it in a different color because it's not really necessary. And then to describe the transformation, this is going to give the same graph as f of x minus, or it's going to give the same graph as f of x equals e to the h. It's going to give the same graph as f of x equals e to the x, but it's going to be shifted to the right 2 units. So for my finish up of the answer, I'm just going to say it's going to be shifted right 2. For 4b, to find the function, this 4, because it's not in a parentheses, doesn't go in the exponent. It just goes after the function. That's the finding each function. And to describe what it does, it's going to shift the graph up 4 units. For part C, the negative doesn't belong anywhere but in front of the function. To find the function, I'm just going to take the negative that's written in front of the f of x and write it in front of the e of x. This is the find each function, and to describe what it does, it reflects the graph over the x-axis. And for part D, to do the find each function, because the x plus 3 is in a parentheses, it goes in the exponent. It doesn't need to be in a parentheses, but it would be okay to have it in the exponent with a parentheses. And the minus 2 comes off to the right after the function. The x plus 3 part is going to shift the graph left 3. And then the minus 2 part is going to shift the graph down 2. For problem 5, I can do that in my head. Probably how I would have done this in the video is to make a prime factor tree for 81 so that both sides can be written as 3 to some power. The prime factor tree for 81 tells me that 81 equals 3 times 3 times 3 times 3, which is the same as 3 to the 4th power. This is kind of side work that I probably could have done in my head. So now I could actually solve the problem by writing the 81 as 3 to the 4th. And if in an exponential equation you can write both sides with the same base, then you can drop the bases. In this case, the bases are 3's. And you could drop the bases and set the exponents equal to each other to get the answer for the letter. And for this problem, once I set the exponents equal to each other, it's real easy to see that my answer is x equal to 2. Question 6 is ugly, and I said you can solve it 2 ways. Now I should do both, but you only have to pick one on the test. And what I'm going to do real quickly is do a prime factor tree for this 16. 16 is 4 times 4, and each of the 4's are 2 times 2. So 16 is 2 times 2 times 2 times 2, which is 2 to the 4th. Let me just try to get it all on this screen. So this is one of the 2 ways. I can think of this problem as 1 over 2 to the 1st to the x plus 1 equals 1 over 2 to the 4th. And then I'm going to use a rule that says 1 over x to the n equals x to the negative n power to make each side written without a fraction. So in the left side, I'm going to use the rule to write this as 2 to the negative 1 power to the x plus 1 power, using that rule that I've written in red. In the right-hand side, I can write this as 2 to the negative 4. Next thing I need to do is clear the parentheses on the left-hand side by multiplying the exponent of negative 1 by the x and the 1. And when I do that, I get 2 to the negative 1 times x, which I'll write as 2 to the negative 1x. And 2 to the negative 1 times positive 1 is 2 to the negative 1. I now have both sides written with the same base. So just like in the last problem, I can drop the bases and set the exponents equal to each other. When I do that, I get negative 1x minus 1 equals negative 4. And then just 2 steps I'll have it solved for. I'm going to add 1 to both sides. That's going to give me negative 1x equals negative 3. And then I'm going to divide by negative 1. On the left side, I'm going to get x. On the right side, I'm going to get 3. So that's the answer that I want for problem 6. And I don't know that this way is easier or harder, but it's kind of messy. So that's one way you can solve it. The second way you can get the same answer is taking the log of both sides, and that might be a little bit easier. And when you go to the test, you only need to pick one of the two ways. So to solve this problem by taking the log of both sides, I would put a log in front of the left-hand side and a log in front of the right-hand side. And I'd put the 1/16 in the parentheses because my calculator's going to need that. Then I'm going to use the rule of logarithms that says if a logarithm has an exponent, you can drag that exponent out in front of the logarithm and multiply it by what's left. For this problem, if I'm doing it this way, the next thing I might do is divide both sides by the log of 1/2. On the left-hand side, the logs are going to cancel. I'm going to be left with the x plus 1. I don't really need it in a parentheses anymore once I get rid of the multiplication on that side and cancel it out. On the right-hand side, I'd have to do that on my calculator. I need to do the log of 1 divided by 16 and then divided by the log of 1 divided by 2. And when I do that, I get 4. So now I'm at x plus 1 equals to 4, which is beautiful. And I'm just going to minus 1 from both sides, and I'll get x equal to 3. So you get exactly the same answer, and you just need to decide which way you like better. They both will give you the same answer, and on the test, you only need to get the answer. It's just whichever way you find more comfortable. For 7, I need to use a rule to simplify the left-hand side. And that rule basically says that if I'm multiplying terms that have the same base, that I can simplify or do that multiplication by adding the exponents. And so this is for the left-hand side. The left-hand side is multiplying two terms that have a base of 4. And if I'm multiplying multiple terms that have the same base, I can multiply by just by adding the exponents and leaving the base alone. So on the left-hand side, I can go from 2 4s to 1 4 by adding the exponents. And now I'm going to add the 3x and the 2x and get a 5x. And I'm going to combine positive 1 minus 3 and get negative 2. So I can rewrite the left-hand side with 4 to the 5x minus 2 equals 4 to the 18th. Now I can drop the bases and set the exponents equal to each other and get 5x minus 2 equals to 18. I'm going to add 2 to both sides. That's going to give me 5x equals to 20. And then I'm going to divide both sides by 5. and my answer is going to be x equal to 4. For the next two problems, I give you a graph of a function that's log base 2 of x, and then I asked you to find a function that's a transformation of it and sketch a graph. And on the test, when I go to do these problems, I'm going to expect you to just do a graph right on the graph that I've already created. So question 8 gives me f of x equals the log base 2 of x, and the first thing it wants me to find is f of x plus 1 plus 3. That's real easy to do. To do f of x plus 1 plus 3, the plus 1, because it's in a parentheses, is going to stay in the parentheses. The plus 3 is going to go after my function. Part B wants me to find the domain of this function. To find a domain of a logarithmic function, I just take what's inside the parentheses, set it greater than 0. I'll minus 1 from both sides and solve for x and get x is greater than negative 1. So for the domain, if I want to, I could just say x is greater than negative 1. Or as an interval, that's the interval from negative 1 to infinity, any number bigger than negative 1. In words, it would be the domain is all numbers greater than negative 1. I'll write this down here. I'll say the domain is all real numbers greater than but not equal to negative 1. Next thing I need to do is describe the transformation. I'm searching for that sheet that I did earlier because it's going to work the same way. The plus 1 in a parentheses is going to shift the graph left 1. The plus 3 after the function is going to shift the graph up 3. So my description for part C, I'm going to scribble it down here, for 8C to describe the transformation, that's going to be a left 1. That's going to be an up 3. And now I'll sketch a graph, and it's going to be the laziest of all graphs. The first thing I'm going to do is put the domain, and help myself with the domain by putting a vertical asymptote through negative 1 on the x-axis, because the graph has to be to the right of this line. So over here, I shouldn't get any graph, because the domain is x is greater than negative 1, which means the graph is only going to exist to the right of that line. And now I'm going to take the graph that's given and just do the transformation. The transformation is to take each point, move it left 1 and up 3. So this is an easy point to move. I move it left 1 and up 1, 2, 3 and make a mark. For this point, I make it left 1 and up 1, 2, 3 and make a mark. For this point that I skipped, this point right here, left 1, up 1, 2, 3, make a mark. This point, left 1, up 1, 2, 3, make a mark. This one, left 1, up 1, 2, 3, make a mark. And the line that I drew at the beginning is going to be the vertical asymptote. So this graph is going to look something like that. So I just drew a graph that looks like the original graph. I took each of the 4 points, each of the 5 points that were given, went left 1, up 3, left 1, up 3, and every time I went left 1, up 3, I marked a point. So 9 basically wants me to do the same thing. It gives me the function f of x equals the log base 2 of x and a graph of that function. And now it wants me to find f of x minus 3 minus 2. Super easy to do. This function, f of x minus 3 minus 2 equals, the minus 3 is going to go in a parenthesis, so it's going to be the log base 2 of x minus 3 in a parenthesis, and then the minus 2 goes after the function because it's not inside the parentheses. To find the domain, I take what's in the parentheses and set it greater than 0, and that's what part B wants me to do. When I solve this for x, I get x is greater than 3, which would be a perfectly fine answer for the domain. As an interval, that would be the interval from 3 to infinity. Or I can say the domain is all real numbers greater than 3. Part C wants me to describe the transformation. The minus 3 inside the parentheses is going to shift the graph to the right, and the minus 2 after the function is going to shift the graph down. So when I go to answer part C, I'm going to say right 3 because of the minus 3 in the parentheses, and down 2 for the minus afterwards. And now to graph it, the first thing I'm going to do is draw a vertical asymptote at 3. So I'm going to go over 1, 2, 3 and make a dashed line through 3. And the graph is only going to exist to the right of this. All the way over here, there's going to be no graph. And I just need to do with the points what I'm told to do. Move them right 3. So this point I'll go right 1, 2, 3, and then down 2. This same point here I go right 1, 2, 3, down 2. This point right 1, 2, 3, down 2. This point right 1, 2, 3, down 2. This point 1, 2, 3, down 2. Every point is going to be moved right 3 and down 2, and they're going to get stuck to the right of that dashed line that I drew. That would be a perfectly fine graph for question 9. Maybe I made it too steep here, but yeah, it doesn't. Maybe it should be more parallel to that, but it hardly matters. It doesn't have to be that perfect. So just 2 more problems for this part of the video. 10 and 11 give me logarithmic expressions, and they want me to rewrite them to something equal to them. Problem 11 gives me a problem. Problem 10 gives me a problem that has 4 logarithms, and it asks me to rewrite it as a single logarithm. And this is super easy to do. My steps tell me how to do it. The first thing is to make any number in front of the logarithms an exponent. So this 2, this 4, and this 5 are going to become exponents of the logarithms that they're attached to. So I can rewrite this problem as the log base 3 of x squared plus the log base 3 of y to the 4th minus the log base 3 of z to the 5th. Oh. Okay, now for step 2, I'm going to write a single log with the base sets in common. So I'm going to write one log with the base sets in common, which is 3. And I said there shouldn't place the arguments in the correct place with the correct signs between them. There shouldn't be any plus or minus signs used on this step. If there is no subtraction, then there's no fraction. If there is a minus, then any argument whose logarithm is preceded by the minus sign belongs in the denominator of the fraction. The rest of the arguments belong in the numerator. So this part right here doesn't apply. There is a subtraction, so there needs to be a fraction. So I'm going to create a fraction, and if there is a minus, any argument whose logarithm preceded by the minus sign belongs in the denominator. The logarithm that has the minus sign in front of it is the logarithm base 3 of z to the 5th. That z to the 5th is the argument of that logarithm. It's going to wind up in the denominator. So this is this part of the rule. If there's a minus, its argument goes in the denominator, and then the rest of the arguments belong in the numerator. We don't get any plus or minus signs, which means we get a times sign between them, which is going to be implied. So the x squared and the y to the 4th are the alternate logarithms that I haven't dealt with yet. They don't have a minus in front of those logarithms, so they wind up in the numerator. The z is already down in the denominator. And that's it. That's all there is to do for number 10. 11's doing this backwards. It gives me a single log, and it wants me to expand it into sums and differences of logs. And for problem 11, I'm going to need to take this log and rewrite it as a sum or difference of multiple logs. And so my steps say write one logarithm with the appropriate base for each letter. In this case, we'll have 4 logarithms because there's 4 letters. So my step 1 of this is going to be to write a log base 3 for the x squared, a log base 3 for the y, a log base 3 for the w to the fourth, and a log base 3 for the z. That's what step 1 says to do. Now I'm going to do step 2, put the appropriate sign between the logarithms. I'm only allowed to use plus or minus signs on this step. If you use a times or divide, you made a mistake. Put a minus sign in front of any logarithm whose variable is in the denominator. The w and the z are from the denominator. I'm going to put a minus sign in front of the w log, a minus sign in front of the z log. The rest get plus signs in front or no sign if it's the first. So the y gets a plus sign in front, and the x doesn't get any sign in front because it's a first. So that finishes up step 2. So I put the signs between the logs. The w and the z got minuses because they're in the denominator. The y and the x would both get pluses because they're in the numerator, but the x doesn't deserve a sign because it's first. So that finished up step 2. So I'm done with 1 and 2. And now step 3 is going to get me my answer when I take each exponent and drag it out in front of its logarithm and make it a coefficient. So the first logarithm I'm going to write is going to be 2 times the log base 3 of x. I'm going to leave the second log alone at the log base 3 of y. The third log I'm going to write minus 4 log base 3 of w. And the last log I'm going to leave at minus log base 3 of z. So in this step I took the 2 exponents and dropped them out in front of their logs. And that's all there is to do. That's the entire answer for problem 11. And that's the end of part 1 of the practice test.